We have a UPS, an APC ES350, which is a 200 watt UPS. We are replacing their 7 amp hour battery with a 20 amp hour battery. I chose this battery based on the manufacturer's ad. It's an AGM battery. Although technically it's not a deep cycle battery, depth of discharge on an AGM gel is about 80%. So you wouldn't want to drain it all the way down to zero like leaving your headlights on. But the UPS, I would expect, is going to shut off somewhere around that range. You want to make your extensions as short as possible. You can see what I made here. This is the negative. This one is the positive. Run the maximum load of 140 watts and see what this thing tells us about any problems with the thermal camera. We're going to use a high quality thermal camera, and that'll tell us the temperature. That'll show us the temperature of everything in here, even the wires. Here's the thermal camera, and I'm going to have to put your camera down while I actually zero in on this thing and measure the temperature, because this is a little awkward. Alright, so it's another day, another experiment. I got a 1.5 amp wall wart, and I just ran that wire up to a terminal block. Okay, that will then go to the fans, which I just got ready for the terminal block. You know, it's funny. Once you become obsessed with an idea, nothing will stop you. Power supply on. Oh yeah, 2 fans. So we got one here. The transformer is actually right in this box. And I'm looking at oh yeah, a lot of wind in there. Okay, there's a lot of wind coming in right there. Okay, so I got a 120 watt load, incandescent load on this thing. I'm running it on this battery with both of these fans going. One in there, one out here, just as a test. Here I go again, holding 2 cameras. You can see that the transformer, there it is the warmest part. I'm going to put the camera down so I can get a temperature reading here. Of course, as soon as I took it apart, it's already on the cool down, but I immediately put my hand on it, and it's not bad. So the reading I got from the thermal camera, the hottest temperature was actually on this side of the transformer, and it was about 50 degrees C. The heat sinks, the 2 major heat sinks, were at 37 degrees. They seem to follow. The hottest part is the transformer. That's what we need to monitor. These heat sinks just sort of follow behind. But we had 50. Generally, we had 46, 47 all around. the transformer, and there was one hottest area back here that was showing on the thermal camera. Not bad. That was 15 minutes of continuous 150 watt load, and this is again a 200 watt UPS, so that's pretty good, very promising. We're not done yet. Well, while I got this thing open, for those of you that want to geek out on my fans, here's the one fan that's inside the battery box. You can see where I put the fan screws and drilled a big hole for the middle of the fan. Here's the other fan that's facing down. This one just has 2 screws holding it in. That's good enough. This one has 4 screws, and we have access holes here. See, these access holes are what allow me to put the screwdriver in and put those screws in. And they also act now as ventilation holes. Okay, yeah, there you go. Now you can see it. All right, so that's how that worked. Okay, so putting this prototype together, I have a 3-volt transformer, 12-volt transformer, and a relay. I just soldered the wires directly to the relays. I added a 2-pin connector that goes to the 3-volt transformer. Don't ask me why. I just like using connectors. So I'll show you how this all comes together. So it turns out inside this box is this perfect little nook for this relay. Just fits perfect. So now let's plug in the transformers and I'll show you what's going on. 2 transformers, one controlling the relay, which is a 3-volt relay, a 3-volt transformer, and a 12-volt transformer going to the fan. The 3-volt transformer is plugged into the surge only. So in other words, when we lose power to the UPS, we lose power to this, and it throws the relay. This is on continuous power. This will have power when we do have AC, and it'll have power when we go to battery. But this one is going to control the relay. So the theory of operation is, as soon as we lose power and we're on battery, the fans kick on. As soon as we get AC back, we don't need the fans. The reason is these fans are noisy. I don't really need them running on all the time, but I do need them running when we're on battery power. Now the UPS is going to lose power. Right here. The UPS just lost power. I can hear them. And there they go. Look at that. Both fans, both of my fans in there are running. Now when the UPS gets power back, they turn off. Okay, just brought this light out. I got a 150 watt load because I want to see that this thing actually works. We're going to now, it's on, as you can see. Here's the light. It's plugged in, so the UPS is on. Batteries are sitting, we're not on battery power, and the fans are sitting idle. Now, the UPS loses power. There's our fans, and our load is still on. So I made this little board, which is a power failure indicator. I had the actual circuit board etched for me by this company here, JLPC Board. I got a deal on having 30 of these made. So right now we have power and the board just sits there. Now in a power failure, kill power to the board. Okay, and of course nothing happens, it doesn't have power. But power comes back while you're gone, while you were out. And now what happens? We got an indicator. It says, by the way, while you were out, there was a power failure. And then you just hit the button to reset it. It's ready for the next power failure. I mean, how many times have you come home and said, was there a power failure today? Okay, so I'm just going to mount it right there on this Frankenstein UPS. Okay, so on the normally closed connection of the fan back there, the yellow one, we go to the fans. The normally open connection of the relay, we go to the power failure indicator. So we're using all 5 pins of the relay. By having the power failure indicator under the control of the relay, which is under the control of the UPS, it verifies not only that there was a power failure, but that the UPS saw it and the UPS responded to it. Alright, so I added a diode, I don't know if you can see it, yeah, right there, to the relay, because now I'm hooking up my circuit and I don't want to get any kickback, so that takes care of that. So this is going to tell me that there was a mains failure of the power, you know, the actual line coming in from the building. And so the way this works, right now we have a load running. I got the light bulb on, and see, there's the light bulb, and now we're going to kill power to the UPS. So the UPS loses power. This thing just sits here, but now the power to the building comes back on. Maybe hard to see on camera where we've got the sunlight, but this thing just lit up. Maybe you can see when I turn it off. Put my finger on the button. Here we go. See? So that just turns it off. So let's watch that again. We lose power to the building. Fans are on. Power comes back on before you return. This thing lights up and it says, hey, you had a power failure today. I got in these thermostats. These are 90-degree thermostats, and I got these this high temperature heat resistant tape, and I'm running a test. It's going to go to an LED that should alert me when we reach 90 degrees C. This is a Class B transformer, so that would mean we still got plenty of headroom, but we're definitely out of our comfort zone. So we'll get an alert that we're getting a little too warm for comfort. So right now we're running the test. We've got it running at 150 watt load, and the fans are running, but they're over here now. The unit is over here, and we're going to see. Now I'm purposely trying to overheat this thing. I want to see if this warning indicator is going to work. Alright, after 40 minutes I never did get these things to react, and I didn't trust this thing. I wanted to test it to make sure it's still working, so I just put a heat gun on it, and yeah, there it goes. So these are working. So this thing, even stuff down inside the transformer this way, I still haven't quite got to 90 degrees C. So I'm going to just go ahead and wire this thing up and put my warning indicator on this. And so I repositioned it. I think I'm going to leave it like that, right up against the iron core, the frame. I'll put some of that heat tape around it. I got it stuffed in behind the factory tape or whatever that phenolic stuff is, plus some of that heat resistant tape for what it's worth to try to hold it in place. And just tested my light just to make sure, because I never did get a reaction out of this. So the thermostat seems to work, the light seems to work. I'm gonna button this baby up. All right, here she is in all her glory. My UPS, it's got an overheat LED here. And we got two transformers. When we switch to battery power, according to those two transformers and the relay we got in here, the fans turn on only when we're on battery. They turn off when we go back to power. We have the relay down here. Here I have a little circuit I made, power failure indicator. If the mains were out while you were away, this will be lit. And you just reset it by hitting the button. This is one of my server rooms. I just noticed I have another 1500 VA UPS here. Forgot about that one. But anyway, so we have here camera server. Here we have different computers doing different things. We have, these are running Unix, and down here, believe it or not, I have a Windows XP machine. We don't go on the internet with that, that's just for camera management. And I do have the UPS that you just saw in the video right here, which is on the main NAS, this one here. And we have a battery on a tray. I don't know if you can see it there. Yeah, and so it's going to be one UPS per unit. So in this case, this thing runs at a nominal 50 watts, 43 right now. It peaks at about 77, so if we're running 80 watts on this 200 watt UPS, we're okay. The fan's running and all that. And so that's pretty much, yeah, the extent of what we're doing. So thanks for joining me on this. This was a fun project.